Hey Algebra 1, it's been a while. I hope you enjoyed your Passover break. Last thing we did was a test, so now we're going to start a new chapter, which is chapter 9, 9.1. For this chapter, we're going to break it into two tests. So after 9.3, we'll test. But as a preview of our schedule, first 2 days we're going to do 9.1. Next 2 days we're going to do 9.2. And then after that 2 days is going to be 9.3. So we're going to take 2 days for each section in 9.1, at least the first three sections. And then we'll have a test after 9.3 on it. So this part, 9.1 to 9.3, is all about graphing these quadratics. Now, from the tests last time we had, last chapter, we were finding what the quadratics equal to. Now we're going to graph these things. But the first version we're going to deal with, there is no bx. And the reason there's no bx, it makes it a lot easier to graph, and it's a little different. But first, let's talk about how this thing looks like. So we're going to use a very basic example, which is just, let's do x squared, okay? So we're going to do x squared. Now we're going to use our domain and range again. So we're going to use a domain and range. Because we're Algebra 1 CP, our domain will always be this. And pay attention to this right here. Our domain is always going to be -2, -1, 0, 1, 2. When I ask you to graph a ax2+c situation, this is always going to be your domain. -2, 1, 0, 1, 2. So whenever I graph, you're going to go from -2 to 2 on your x's. Alright, so this is, I should say, y equals x squared. So we plug in our x's to get our y values. So first let's plug in -2. -2 squared. Remember, -2 squared is -2 times -2. So that's going to give me a +4. -1 squared. -1 times -1 gives me a +1. 0 times 0 gives me 0. 1 times 1 gives me 1. 2 times 2 gives me 4. So all I did is just plug in my x values into this table. Now, what does this all tell me? Well, how does this look like as a graph, I guess is what I'm looking for. So these are all x and y coordinates. So -2, 4, that's 2 to the left and 4 up. So we have a point here. -1, 1, that's 1 left, 1 up. So something here. 0, 0, right at the origin. 1, 1, that's 1 right, 1 up. And then 2, 4 is 2 right, 4 up. So we get this U shape. And let me make this U shape nice. And because we only use 5 points, sometimes it looks like a V. But it's more of a U shape. And the official name of this shape is called a parabola. You might have heard of this name before. So this is called a parabola. I'm not going to pretend I know how to spell it anymore. So I'll put it in the comments later. But this is called a parabola. So it's that U shape. Before, when we graphed, it was always a straight line. In this section, they're always going to look like a parabola. Okay? So this is a very basic one. So let's talk about what's happening here. And we're going to go over steps. And again, I'll write my steps for on the actual post. Let's identify what A and C was in this one. Well, A in here is the number in front of x squared. But there is no number in front of x squared. So that just means it's a 1 because you don't see it. And in C, you're adding something that doesn't exist. So when you add something that doesn't exist, that's like 0. So your C was 0 here. And on the next one that I'm going to do, I'm going to show you what both A and C does. Okay? So we're going to do a couple of examples of this, and I'll go through the steps. All right. So we have our first one here. Now I'm going to ask you to identify the A and the C. And this first part where we're just graphing, identify that A and C doesn't do anything, but I want to practice because it's going to be very important later. But when we first graph this, so this like first day of lessons, are telling us what A and C doesn't really do anything. We still do the math regardless, but I want to practice that early. So your step one is to identify A and C. Now, there's no B in the equation, so you always assume B is 0 in this case. Like you don't see a normal x, and it's just a reminder, what did it look like before? It was ax squared plus bx plus c. There's no x at all, so that means it's a 0. When there is an x, it changes the question completely, but that's all in 9.2. So that's why we're just focusing on just the A or C, or both, okay? So A is going to be 3 here, because it's the number in front of x squared, and C is 0. It doesn't change anything. So now let's do it. So step one is to identify your A and C. Step two is going to be to make your table with your domain of -2 to 2. Like I said, your domain will always be -2 to 2 in this question. When I ask you to graph, it's always going to be -2 to 2. Then our next part is to plug it in, our domain, or our x's, into our equation and find each piece. So let's do the first one. 3 times -2 squared. Well, that's 3 times 4. So that is 12. So this one's 12. 3 times -1 squared. Well, that's 3 times 1. That's 3. 3 times 0 is 0. 1 times 3 is 3. 2 times 12, or 2 times 3, no, 4 times 3, I apologize, is 12. 2 squared is 2 times 2, which is 4. 4 times 3 is 12. Now I want you to notice something. What do you notice here? Some kind of pattern is happening. I want you to notice that the pattern is, let's say this right here is going to be called our vertex. The middle is called the vertex. Here and here, and look at that, U shape appears again, are equal. And here, the two points are equal. So what we call this is that our graph is symmetric. So this is going to be a method to check your work. You're going to check your work by just checking and see, hey, this and this is equal, so I must have did that right. This and this is equal, I must have done that right. And let's just go to the graphing. Now I know, well, I don't expect anyone to really have graph paper, so I'm not going to judge on the accuracy. So like this is how accurate I would expect. So let's just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You just put 12 marks here. -2, 12, so all the way up here. -1, 3, so 1 left, 3 up. 0, 0 again. Comma, +1, 3, so 1 right, 3 up. +2, 12. And then you make your U shape. And particularly compared to the last one, it's a lot more skinnier. Okay. So those are the steps, and I'm going to just do more examples. And I wanted to point this out right here. The middle of your graph, which on the parabola is going to be that tip, the bottom tip, is our vertex. So I'll put that in the definitions also in the description. So the vertex is that, okay? All right. So this is the next one. And what's going to be slightly different is that we have an A that is negative. So first let's identify. A is -2, and C, again, we don't see it being plus or minus anything, so it's 0. So our A is -2. Let's see how that affects our things. So you have to make your table and make your domain from -2 to 2. This is your next step. I just pre-write it to save some time on your video. Then we're going to plug it in. So let's do negative 2 times negative 2 squared. Negative 2 squared happens first. So negative 2 is positive 4 times negative 2. This negative does not get involved with the square in this situation. Negative 2 times 4 ends up being negative 8. So we got a negative 8 here. All right, let's plug in negative 1. Negative 2 times negative 1 squared. Remember, negative 1 squared happens first. So negative 1 times negative 1 is positive 1 times negative 2. That's negative 2. So we're going to put a negative 2 here. Over here is 0. We're going to do 0 squared is 0. 0 times negative 2 is still 0. 1 times, I guess I'll just rewrite it. Negative 2 times 1 squared. That's negative 2 times 1. So that's negative 2. And negative 2 times 2 squared. That's negative 2 times 4, which is negative 8. So negative 8 here. I don't know why I circled that. Okay, let's do a little quick, this is called the parabola check. So we're going to check if it's symmetric. So this is symmetric. So that's good. And that's symmetric. Okay, that's good. So because they're both symmetric, I'm pretty sure I did it right. I didn't make any mistakes. So, sorry for the weird cut. My camera roll got full apparently. I don't remember what the last thing we did, but I'm just going to say, since these match, we're pretty good. I'm going to do about 1 or 2 more examples. The next one's definitely going to have a C in this case. All right, we're on our next one. Y equals x squared plus 3. So again, step 1, even though it doesn't effectively do anything in this on this question, it's good to identify. So A is going to be 1, and C is going to be positive 3. So let's just plug in our numbers and solve for each y value. So negative 2 squared plus 3. Negative 2 squared is 4 plus 3, 7. So 7 is your answer here. Next one. Negative 1 squared plus 3. That's going to be a positive 1 plus 3. That's 4. So 4 is going to go here. 0 plus 3 should be just 3. 1 plus 3. 1 squared plus 3 is 3, or 4. And then 2 squared. 2 squared is 4. Plus 3 is 7. Okay. So the difference is the last 2 or 3 examples, I lost count, it was always 0, 0 at the vertex. Well, first let's just do our check exercise. Hey, this works out. And this works out. So our parabola check works. It is symmetrical. So this right here, 0, 3 is our vertex. And let me just graph that to show a little bit of an example. So 0, 3 is a vertex. Oh, I know what I forgot in the last one. I apologize. The video, the camera dying kind of messed me up. The last one, because it was a negative a, this was the last one, which I believe was negative 2x squared. I just want to show this. Because it was a negative a, it's going to open like this. So it's going to be downwards. So negative a causes it to open downwards. So you could do that mental check when you see it, like, oh, I had a negative a, and some reason my graph looks like this. If that happens, then you made a mistake, and you got to try to figure out what you're doing. You're probably messing up the negatives or anything. So that was for the last question. Let's go to this question, which is x squared plus 3. So we got negative 2 comma 7. So 2 to the left. 1, 2, 3, 4, 5, 6, 7. So 7 up here. Negative 1, 4. So 1 left, 4 up. 1, 2, 3, 4. 0. 0 left or right, and then up 3. 1 right, up 4. 2 right, up 7. So now, it still looks like a parabola, but the thing is, the vertex is now in a different spot. It's not at the origin anymore. It's here at 0, comma 3. So our vertex here changes where C is. and I'm going to put this in the comments of the post, C changes the y value of our vertex. C changes the y value of our vertex. And I also want to state that it's also the y-intercept. It's where it hits the y-axis. So C is going to be two things on this situation. The y-intercept and the what we call the min or max value. Now, what is a min-max value? Well, this is the lowest it goes. So this is the lowest it goes. So how low is the y value here? It happens to be 3. So this is the min value. If it was like the negative one over here, how high does this graph go? Because it goes down forever, so there's no minimum value. So how high does it go? This one, the max is 0, okay? While here, the min is 3, because the lowest is 3. So the letter C gives you two things in this situation: your y-intercept and your min or max value. It's a minimum because it goes up this way, so there's the lowest point, and it's a maximum because it goes down this way, so there's the highest point. So you got to make sure, and part of your homework is going to be to identify the min or max value, okay? It's because I'm not going to expect beautiful graphs, I'm going to ask you different more qualities. From that point on, I'm pretty happy with what you got. We'll end for today here. Next time, we'll talk a little bit more about the details and talk about a little bit more about how do we compare two graphs, okay? So again, I hope you enjoyed your break. This is going to be due to the next time we have class, and I'll post it on Google Classroom because I don't know offhand. I believe it should be Thursday. All right, have a wonderful day, guys.